The domains of continuous and discrete graphs. So we're finding the domains. As we know, domains mean the x values. So we're going to talk a lot about graphs and the x-axis. So first we got to define. This is actually on your lower left corner of the front side. Can you guys go to that lower left corner of the front? And we need to talk about the vocab before we start. It's not a good idea for the vocabulary to be at the bottom of the paper because how does that help us? So let's do that first, okay? A continuous graph. Here we go. A continuous graph, the points on the graph are connected with a line. The points on the graph are connected with a line. And if you think about the word continuous, it's like a line on a graph. A line continues on, it never stops, it moves. So points that are connected on a line are continuous. The line just goes on and on, continues. All right, discrete. And this discrete's easy. Unconnected points. Just dots, random dots all over. No line touching them, no line connecting them, just dot, 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 dot. And then the next thing I want to do is how to find the domain. Okay, the domain on a graph is going to be the x-axis. So when I look at a graph, I'll draw one real quick. When I look at a graph and I want to talk about the domain, what that means is all of the points that are going to, they don't have to touch that blue line, the x-axis, but like if a dot were right here, then what I would say is that this dot is actually on 2. See how it's on 2, the blue dot? Let me make the blue dot bigger. See how that blue dot is on the line, x equals 2? So I would say that the domain would be at 2. So it's basically that blue dot does not touch the x-axis at all. But if I were to make, a line going through it, it would hit at 2. And I will explain more as I go, but basically we're looking at the x-axis for all of this. We're looking at the x-axis to help us with all of this. Now, is this, looking at your definitions, is this continuous or discrete?
Discrete.
Discrete. Dots, discrete. Dots, discrete. Are you guys laughing at me? That's all right. I will make a fool of myself if it helps you understand math. But I think you know that already. All right. Here's the deal. I am now not going to connect the dots. Don't put them together. But what you are going to do is you are going to look, and I'm going to use a color here. Here's my x-axis. It's in red. If I were to draw lines, and so these lines would be connecting my dots to the x-axis, where would my fake lines be? Like here's a dot, black and blue, right? What line is this? X equals what? -1. How about this one in the middle? X equals 0. How about this one right here? X equals 2. So what you're doing is you're predicting where would lines hit the x-axis if I drew lines. And that's what's called the domain. Where would the x-axis be hit? So here's how you're going to write it. the domain equals, let me have these like fancy brackets. Psh. Here, I'll make one really big. Watch the board. Don't look at your paper. Watch the board. So, look at the left of the graph, please. It's like this. They're like really weird brackets. They're not squared off. They're not curvy parentheses. This is the way the bracket looks, and the other side looks like this. And you know, it just takes practice. And even that one, the right side looks like honky. It doesn't look very good, you know? But the point is, this is what you need to do. X equals all the numbers that we just said. -1, 0, and 2. And then close it. Boop. Boop. Okay? The domain is at -1. The domain would hit at 0, and the domain would hit at 2. Because those would hit on the x-axis. Sorry. Is this discrete or continuous?
Discrete.
Duh. Would that be mean if I were like, duh? It's discrete, duh. I won't do that. That's mean. So now I care just like I did last problem. If these dots were to hit my blue x-axis, they'd hit at right there. That one too. There. There. 4 places. And I've got to tell, domain is fancy schmancy. What are the 4 places that these dots would hit the x-axis? What are the lines at? -2.
-1.
-1.
1, 2.
1, 2. And then go psh, psh. Fancy parenthesis. This is a form of a bracket. They're like set. It's called like set notation, and what it means is it's a different way to write a set of numbers when we're talking about functions. The set of numbers in the domain is -2, -1, 1, and 2. I am moving on. Is this discrete or continuous?
Continuous.
Are you guys like good at cursive?
No.
Yeah.
Continuous. You can't read that?
I can read it.
Yeah, I can read it.
I can read it.
I'm bad at writing it.
Also good. I can read it. I can't write it.
Oh, well, I guess my generation, you know, us old people, we had to do a lot of cursive. You had to as well? You just gave it up because you don't have to. It's like you pick. Once you get past 6th or 7th or 8th grade, you're like, what do I want to write? Do I want to write just normal print or do I want to do cursive? You know, you don't have to do cursive.
That actually sounds pretty great. Yeah.
Now, if, like I care, where would it hit my blue line x-axis? So where does this continuous line hit? You're right, it only hits in one spot. My domain only hits in one place. And by the way, this would not be a function, but we don't care about that today. But I'm just saying, you know, connect it to last lesson. It would not be a function. So that was easy. Next problem. Is this continuous or discrete?
Continuous.
You were so right. And, all right, here's my issue. I care where it hits my blue line x-axis. Can everybody look at the board? This line has arrows. I'm going to continue with the black line. It goes on forever and ever and ever and ever to the left. It goes on forever and ever and ever and ever and ever to the right. Eventually, it'll just go all the way to the left. If I give it enough spaces, that line will just be like up, 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 negative 100, negative 1,000. You're just going to go on forever. And then this one is going to go down. So it's going to be like 1, 2, 3, 4, 5, 6, 7. But it's going to go forever and ever and ever to 100, 75,000, whatever. The point is that eventually every single line was going to get hit. Do you get the point? Because even way down here, that black line is going to be way down, and it's going to hit. The red line and the black line are going to hit all the way down here on the lower right, here. Okay? So the reason I bring this up is because every single number negative is going to get included in the domain, and every single number positive is going to get included in the domain. So you're going to write this. The domain is going to be every single number ever. It's a special R. So everybody draw an R, and then watch what I do with my red line. It like goes down the middle. So it really looks like this. Or like, I mean, there's so many ways you can do it. You just make it, there's 2 lines in the R. That's called all real numbers. So when I draw something that says an R, it means every number that you can ever think of is included in the domain. Any number that you could ever think of is included in the domain. All the negatives. Negative 7.2. Positive 14.68. Anything. Fractions, decimals, whole numbers. Any. All right. Let's talk now about this one. Is this discrete or continuous?
Continuous.
You're right. It is continuous. And let's talk about the domain, because you know it goes on forever and ever and ever to the right. Forever and ever and ever and ever to the left. So where is my domain going to hit?
All real numbers.
You're right. Domain. Make your set notation. It's like a special bracket. R with that special line down it. What it means is all real numbers. So good. Okay. Well, this, by the way, is an absolute value graph. If you were to graph this, the equation would have absolute value brackets around it. Okay, here we go. Is it continuous or discrete? Continuous. So since this is continuous, tell me now, the domain. What numbers are included in the domain? What numbers are included in the domain? All real numbers. You're right. All real numbers are included in the domain. Because it's going to go forever positive numbers, forever negative numbers, like that. What?
All real numbers if you're like vertical?
Yeah, slanted lines and such. Yes.
So it doesn't matter if it's like a V.
Doesn't matter that it's a V. Okay. So, all the problems that I've just done, like the third one, line up and down, the fourth one, slanted line, the fifth one, slanted line, and the sixth math problem, the V, they all have equations. So now I'm going to give you an equation in y equals mx plus b, but I'm not going to draw the picture. Because I don't have to draw a picture for you to be able to do domain and range. I don't want to know if this is continuous or discrete because I don't have a picture for you. But what I do want to know is the domain. So that means what numbers could I use for x? Or what numbers could I plug into this math equation for x? Can somebody give me some sample numbers that I could maybe plug in for x? 4, sure. What else? 0, what else? 6. What else? 2. -5. 200. Do you guys see a pattern here? Can you think of a number that I can't plug in?
24.
I could plug in 2 times 24 plus 1. I could plug in anything. I could plug in any number that I can think of. I can plug in all numbers in the whole world. So I could plug in all real numbers. Any number can be plugged in. Okay? Here we go. Now, whenever you have like a math problem that has, you could put like a 2, you could put like -75.3. What would not look good at the denominator? Another fraction? You're right, but I really could do this math problem. I just move by multiplying by the reciprocal, and it still works out. Can you think of another number that wouldn't be good at the denominator? -1. No, I got that. What else?
0.
Ooh. When 0 is under, it's undefined. So here's my point. 0 can never, and that doesn't even sound right, 0 can never be in the denominator. So, I could put any number there underneath the 3, but I couldn't put 0. So here's the way you're going to write that. So you can put any number, but you can't put 0. Looks like this, watch. The domain is special set notation, all real numbers. Now, the punctuation mark of a semicolon means it's like a new thought or like a second part of a sentence, right? So I'm going to put a semicolon because I'm putting in a new thought. And my new thought is any number, but it can't be 0. So I'm going to put x cannot, equal sign with a line through it. Equal sign with a line through it, cannot equal. Equal sign with a line through it, cannot equal 0. So let me read this to you again, what I wrote in math. Because math now has its own language today for our lesson. The domain is all real numbers, but x cannot be 0. That's what I just said. The domain is all real numbers, but x cannot be 0. Let me look, I'm making up another problem, guys. Please look at the board. I'm going to write it underneath my squiggly line. What if I had something like this? (55 over x minus 7). So here's what I want to ask you. I just wrote in red on top, 0 can never be the denominator. So that means that for x right here, I could put any number that I want, because I could do, 23 minus 7. I could even do 0 minus 7. So I could plug in 0. But what number, if I plugged it in, would make x minus 7 be a 0?
7.
And you do it like this. 7, bad news. Because if I plugged in a 7, I would get 55 over 0. Oh, can't do it. So, your answer is going to be, the domain can be any number, but what can't it be? Because then I'd have a 0.
7.
X equal sign slash through it. X cannot equal 7. Any number I can think of, but it can't be 7. Because 7 minus 7 is 0. And it doesn't matter what you do. I'm going to do another one on the side. Look over here, guys, on the far left. 2 over 3x minus 5. No, that's too crazy. I don't want to go crazy on you. Do you guys want me to go crazy on you? No. Hold up. Hey. Let's say that were mine. Y equals 2 over x plus 4. So here's my question for you. What can I not put in the denominator? What number, if I plugged it in, would get a 0? And here's how you do it in red. X plus 4 equals 0. What number would that be? If x were negative 4 and I plugged in negative 4 for x, I would get a 0 on the denominator. It's super easy to figure out what it is. You just set your denominator equal to 0. The domain is all real numbers. X cannot be negative 4. Okay? Tell me your understanding level on this lesson. Like easy, middle, thumbs. Show me your thumbs. Or down. And if it's side or down, then maybe I'll come hang out with you. And we'll chill and we'll do math together. Okay, so good. All right, now you only have a